Today we're looking at solving systems of equations using substitution. Here are the guidelines. You are given two equations of lines. You need to find the intersection point. Let's name the two lines to make it easier to sort them out. One called red, one called blue. Pause the video and copy these two equations in your notes. If you have a red pen and a blue pen, it would be helpful to color them in that color. The first thing we need to do is determine which equation, red or blue, that is the easiest to isolate a variable in, y equals or x equals. Let's suppose that is blue. Solve the blue for the variable. Let's use the variable x. Please pause the video and solve the blue equation for the variable x. Please pause the video and check your work. Okay, now we're going to substitute the newly solved blue equation into the red equation so that there is only one variable left in the red equation. So we're going to take the value of x and substitute it in to the x in the red equation and get the following. 3 times the substituted equation, which is 5 minus 3/2 y minus 4y equals 8. So we substituted the x value from the blue equation into the x value of the red equation and eliminated the x variable. Please pause the video and copy this into your notes. Okay, the next step is to solve the system of equations, solve the equation that's left for the variable y, which is the only variable in the equation, doing some algebra. First thing we're going to do is distribute the 3, and we end up with 15 minus 9/2 y minus 4y equals 8. Then we're going to collect like terms, which would be the 9/2 and the 4. When we subtract the 9/2 minus the 4, which is also could be written as 8/2, we get 17/2. Now we're going to subtract 15 from both sides and get negative 17/2 y equals negative 7. Let's copy that over here. We're going to multiply both sides by negative 17/2, the reciprocal of negative 17/2, which is negative 2/17. And we get positive 14/17 is our y value. Please pause the video, copy this in your notes. Note that you could have changed these to decimals if the calculations were easier for you. Okay, last step. We're going to substitute the value that we found, y equals 14/17, into either of the two original equations. It's entirely up to you which equation you use. Please pause the video, substitute the y value into either of the two equations, and solve for x. Then play the video to see the solution. I substituted the 14/17 in for the y value of the blue equation. Then I did the following algebra in order to find out that x is 64/17. So I can now write the intersection point of the two lines as x 64/17, y 14/19. If you prefer to write in the form of a decimal, we could have done x is 3.76 and y is 0.8. Please pause the video and copy this into your notes. Now your turn. Here's two equations, a red one and a blue one. Find the intersection point using the guidelines above. Please pause the video and work out the problem. When you're done, look at the solution. Here's one way of doing the problem. I decided that x plus y equals 5, the blue equation, was the easiest one to solve for y, or for x. I decided to solve for y. Then I substituted the 5 minus x in for y into the red equation. Then I used the distributive property and did the rest of the algebra to find out that x equals 3. Once I found x equals 3, I went back to one of the two original equations. I decided to plug into the red one. You could have decided to plug into the blue one. Doing the arithmetic, we find out that y equals 2. Also note that if we had plugged into the blue one, we would have had 3 plus y equals 5, or y equals 2, which is the same solution. So we know our intersection point is at the point x is 3, y is 2. Please pause the video and copy this in your notes. You may have to rewind to get all of the notes.